Let's take a look at inconsistent dependent equations by matrices. We're going to take a look at our first problem here. So we got 3x plus y plus z is equal to 2, and 4x minus 2y minus 5z is equal to 1, and 6x plus 2y plus 2z is equal to 4. I'm going to double check all my numbers. Okay, we're going to use the calculator to do this, so we're going to use RREF. So I got 3, 1, 1, 2, 4, negative 2, negative 5, 1, 6, 2, 2, 4. I drop the x's, y's, and z's and equals to keep the numbers in their signs. Now the size of this matrix, rows by columns, this is a 3 by 4. So 3 rows, 4 columns. Let's go input this into our calculator. Okay, so clear there. I'm going to do a second x and negative 1. That's actually the inverse button, but I'll refer to it as x and negative 1 because it's easier to see for students, I believe. We're going to go over to edit, so I right arrow twice over to edit, and I'll do enter on A. And that's asking us for the rows, which we said was 3, so I do 3 enter. And that's asking us for columns, so I do 4 enter. And then we'll just type in each number, pressing enter after each one. So 3 enter, 1 enter, 1 enter, 2 enter, 4 enter, negative 2 enter, negative 5 enter, 1 enter, 6 enter, 2 enter, 2 enter, and 4 enter. And let me double check all that. That looks good. Exit out. Now I'm going to do RREF, reduced row echelon form. So I do second x to negative 1, right arrow to math. Well, by the way, I exited out by doing second mode. I'm not sure if I said that. So let me start over. Second x to negative 1, and then I'll right arrow to math, and up arrow to RREF. Make sure you choose one of 2 R's. Press enter. Then we'll go back into our matrix menu, second x to negative 1, enter on A, and enter again. We get decimals. That's okay. We know how to handle that. We press math, enter, enter. And let's write down what we got. So we got 1, 0, negative 3/10, 1 over something, probably half, but maybe not. And then 0, 1, 19/10, and maybe 1 over 2, probably 1 over 20 though. And last row is all zeros. Okay, now these 3 little dots over here on the right hand side means there's more to the right that we can't see. Possibly more. So we'll press our right arrow key, and those are 1/2. They're not 1 over 20. So this is what we came up with. Now if we look at our first 3 by 3 matrix, the reason why I said 3 by 3 is because we got 3 equations, 3 variables. So we look for the first 3 by 3. It should be a diagonal of 1, zeros, or else. It isn't. Specifically, the last row is all zeros. This is our first oddball case. This is where we put our variables back in. So I put my x here, y here, z here, and equals. I put my x, y, z equals. You could do it on the last row if you wanted to, though it doesn't go anywhere. 0x is 0, 0y is 0, 0z is 0, so you get 0 is equal to 0. But the first row gives us x, and 0y drops away, minus 3/10 z is equal to 1/2. Second row gives us 1y or y plus 19/10 z is equal to 1/2. Now our first row, we're going to solve for our first variable, which is x. So we're going to get x is equal to 1/2 plus 3/10 z. I took the negative 3/10 z to the right side. On this one, I take the 19/10 z to the right side, and I get y is equal to 1/2 minus 19/10 z. So we're solving this one for x, we're solving this one for y. Typically, our answer is of the form x, y, z. Well, we know what x is, we just found it. So this is x, so we'll put in 1/2 plus 3/10 z, comma, y, well, we just found that, that's 1/2 minus 19/10 z, and our last one is just z. Typically, books will put a variable in for z. These are dependent equations, and this is what happens when your last row is all zeros. That's what that means, is dependent equations. Let me put a t there, even though I don't make t's very well. 1/2 plus 3/10 t, comma, 1/2 minus 19/10 t, comma, t. And that would be your answer. Now, some books will just stop at saying it's dependent equations. They don't have you go further like this. Let's look at our second oddball case. We got x plus y minus 3z is equal to 4. And we got 7x minus y plus 2z is equal to negative 1. And 3x plus 3y minus 9z is equal to positive 1. Now let me double check all those. Okay, now let's write down our matrix. Again, we'll drop our x's, y's, z's, and equals and keep the numbers in their signs. So I got 1, 1, negative 3, 4, 7, negative 1, 2, negative 1, 3, 3, negative 9, 1. Let me double check all those signs. And this is a 3 by 4, rows by columns. We've got 3 rows, 4 columns. And let's put this in the calculator. So I'm going to do a second x and negative 1 to go into the matrix menu. Right arrow twice over to edit. I already got A highlighted, so I do enter on it. It's asking me for rows by columns, so I do 3 enter, 4 enter. And I do 1 enter, 1 enter, negative 3 enter, 4 enter, 7 enter, negative 1 enter, 2 enter, negative 1 enter, 3 enter, 3 enter, negative 9 enter, and 1 enter. And let me check my signs. 4, negative 1, 1, and check my numbers too. Negative 3, 2, negative 9, negative, or 1, negative 1, 3, 1, 7, 3. Now I'll exit out, second mode. Okay, now let's do RREF. I'll do second x negative 1, right arrow to math, up arrow to RREF. Make sure you choose one of 2 R's. Press enter on that. Then go back to my matrix menu, second x negative 1, enter on A, enter again. We get decimals, that's okay. We do math, enter, enter. And let's see what we got. 1, 0, negative 1/8, 0. 0, 1, negative 23 over 8, 0. And 0, 0, 0, 1. First off, we got 3 equations, 3 variables, so our first 3 by 3 should be a diagonal 1, 0, 0, everywhere else, if it worked. Obviously, I don't got a diagonal 1, 0, 0, everywhere else, so it failed again. And specifically, my last row is all zeros and a single 1. If it's all zeros and a single 1, that means that there's no solution. Or, what this book that we're currently using refers to it as is inconsistent. And that's how you tell the difference between your inconsistent and dependent equations. You don't go any further on this one, by the way. This is a simpler one. So this is working with inconsistent dependent equations on a TI-84 plus calculator.